So hi everyone, welcome to the R2 hall, and I'm the host of this session. My name is Kevin, and here are some friendly reminders. So we have HackMD for collaborative note-taking, and we have Slido for question answering, and also we have Discord server for discussion or any further questions. And those links have been put on our Discord server and also on our website, so feel free to visit them. And this event is also supported by many sponsors, so feel free to visit their websites and their booths, have some interactions. And I'm going to introduce the speaker of this session. So Wei Lee has been a volunteer of PyCon Taiwan since 2019, and he was the chairperson of 2021, actually. And he's also an open source enthusiast. So he's a committer of Apache Airflow and also a maintainer of commitizen-tools. By the way, he will also host the Airflow project at a sprint event on next Monday, so feel free to join the event if you're interested. And I also know that this talk is related to his recent work on the Airflow project. So let's welcome Wei to start his talk.
Yep. So yeah, before everything started, here is the QR code to link to the slide deck. So yeah, if you want to follow along, just scan it. I'll stay here for like 10 seconds. Yeah. Okay, I guess it's time's up. So yeah, I believe everyone's here for the chaos stuff I just mentioned in my title. But you might ask, why chaos? Then yeah, the truth is, yeah, it's more attracting. So many people are attracted by the chaos stuff, I believe, because the title looked interesting. So the fact is, we are still going to build a normal linter. Yeah, I mean, at least for now, we are going to do something like this. Oh, people still coming. So, yep, we'll continue anyway. But the next question is, why do we need a linter? Because you already have rough, black, and PyLint, and like flathead, and all those kind of stuff. Yeah, but sometimes you just need to customize your role a bit. So that's why we want to build a customized linter. And you might ask, such as what scenario? Then I'll tell you a true story I recently working on during this pull request in Apache Airflow. You don't actually need to know the detailed implementation of this one. You only need to know we require all the existing and all the future class that has a differable argument in its dunder init method to be this one. Yeah, this giant conf.get boolean stuff. And so this is an example of it. If you set differable equal to true, it's not acceptable. If it counts without default value, it's not acceptable either. But if you set differable to this value, it's perfectly fine. And this is what we want. So what can we do to enforce this kind of stuff in Apache Airflow? Yeah, of course we can just kindly ask our contributor and maybe ask the committer to not merge the pull request without following the rules. Or what we did is actually building a linter. And what we are using is AST. And you might ask, what is AST anyway? So it's abstract syntax tree, a way to represent your code in a tree structure. Yeah, so this is a minimum AST example. We use so this is quite minimum because your source code only contains A equal to 1 plus 2. And then we try to pass it into an AST, and then we try to dump it here. So yeah, you can understand what the tree looks like. So under the hook, it looks like this. And let's visualize it a bit. It would become something like this one. And yeah, the first node we encounter is an assigned node. And the target value of it would be a nan, which is a variable which we are going to store something into this variable. And the value we are going to store would be a binary operator. Yeah, the left side of this binary operator will be a constant 1. And the operator we are actually doing is adding something. And the right side is a constant 2. So that's a basic idea of an AST. And let's go back to our real-world example. Yeah, this is what we want to do. And this is, so this is the AST we pass after we pass this one. So even for this simple one, we'll have such complicated AST, so it's not possible for human to like analyze. I mean, you're not going to read it one by one, so you will need to use some programming method to check all this kind of stuff. And let's go back to the requirement. We require all the default value of the argument differable in all the dunder init method of any class to be this one. And let's try to formalize the step a bit. We need to first search the class definitions in all your modules, and then all the dunder init method in your class definition, and then all the argument node in the dunder init method. If they are named as differable, then we'll check where the value is it. So yeah, as you might notice, there's the argument, assign, and all those kind of different nodes in AST. So let's formalize it into the AST term. So we search for the class definition node in your AST, and then we try to find the function definition with a named dunder init. And among all the arguments in the dunder init function definition, we need to find the one with differable, the named differable. Yeah, and we'll check where it's actually this value. So after you try to write a linter, the first step is that you want to iter through the top level of your AST, because we kind of assume all the class should be defined in top class, and that's what Airflow do. I know, yeah, Python is free, so you can do many magic, and you don't necessarily need to define class in top level, but that's what we do. So, yep, we then check where this node is an ast.classDef, and then we iterate through these nodes and try to find the function definition with named dunder init. And we then pass this one into another for loop and try to loop through its arguments and its default value. But because AST does not bind the default value and their argument together, so we'll need to do this kind of stuff. And the reason why we need to reverse it is that because an argument without default value cannot come after ones with default value. That's not acceptable by Python. So we need to do this kind of reverse and try to leap out of that, because some of the argument might just not have default value. So we need to leap longest. Yep. And the check-in is here. If it's not differable, then it's fine. It's not something we want to check. And if it comes without default value, then it's an error. And if it comes with a default value, then we'll need to check whether the default value is correct. So that's our next step. Here, we pass the default value here. We check where it's AST code, because it's conf.get boolean stuff. And you can see there's a lot of like attribute where the ID is conf and get boolean. And yeah, if it's not, then we'll just return false. And if it is, then we'll need to check the value inside it. Operator, default differable, and fallback, and all those kind of stuff. But actually, what you need to do is to unpass the default value and check where this is expected. So yeah, all those kind of complicated comparison here and here can be simplified in this way. So that's so much for that idea. And what if we can do one step forward, like building an auto formatter? Yeah, if you go through the AST documentation, you'll see a node transformer, which you can use it to change the node inside your abstract syntax tree. And you'll also find another thing is node visitor, which is something we probably should use in the previous example. But yeah, by the time I didn't know we have this kind of stuff. So yeah. So node visitor actually works pretty much the same way as node transformer. So I'll just introduce the node transformer here. Yeah, so first we'll need to create a customized class inherit from the node transformer. And then the syntax is this. We'll need to define a function, visit like each kind of node type. Like you can visit a class definition, or you can directly visit the argument or some variable name. But in our case, we can first visit function definition because we assume Linter init method only exists in class definition, so we don't need to do a class definition checking here. And after that, we'll do the checkings. So the logic above is basically the same as we just introduced, so I'll just skip that and focus on this one. So the expected default AST is the AST with the default value, but we just pass it as an abstract syntax tree, and we assign this value back to the node we want to assign. So yep, that's how we build our transformer. And now we try to build a default differable transformer, and then we use this transformer to visit our AST tree. Actually, I feel AST tree probably is not the best name because AST already abstract syntax tree, so it's like abstract syntax tree, which like the Indian stuff like naan bread or like chai tea, if you ever watch the Spider-Man movie, that's the joke inside it. And yeah, and because you are adding a node, so the line number will be different. So AST provides this function so that you can fix the missing location or the additional location of your abstract syntax tree. And we'll, because there we already fixed our tree, so we just unpass the tree and write it back to your module file. And let's see how it can be fixed. So here it's a differable, and yeah, there's a command that's going to be fixed, and this is actually going to be fixed. And let's see how it works. Yeah, ta-da, it's actually fixed, but something is not right. Like all the commands, all the formats are gone. So that's how AST works. AST does not preserve all the details. So yeah, it turns out check was right. Check talked about another library from PyCon APEC last year. So she talked about libcst, and yeah, again, we'll discuss why we should use it. So it actually preserves more details. For this module, we are going to this a equal to 1 plus 2, and with the comment here again. And the upper one will be AST, and the lower one will be CST. Let's see how the difference are. So this is AST we just saw in the previous example. And this is CST. There's way more detailed. Yeah, it preserves more information inside it. And if we visualize it a bit, it would look like this. And yeah, because I believe no one can actually see this graph, so let's run it a bit. So it actually preserves the trailing space here and the white space and all the comments and how they try to do the new line stuff. So that's how the libcst build up the concrete syntax tree. And it also provides more features like metadata provider. You can get the parent node of the current node, so it's easier for you to track pretty much everything. And the scope metadata, which is quite important if you are doing some refactoring because you don't want to change, rename the variable which are in different scope but with the same name. And also it comes with some more code modules, like you can add imports or remove the unused import. It can also gather unused import as well. So yeah, it's quite powerful actually. So let's try this again. So yeah, we are going to use CST transformer this time. And the syntax is a bit different, but not quite different. So besides visit node, it also supports leaf node as well. So the idea of this design is that when you visit your tree, you can try to gather the information you need related to this node. And when you finish your traversal, when you leave the node, you can do some operation on this node. So that's the philosophy behind the libcst stuff. And it also provides a better way to pass parameters. So you don't need to do the argument and default value binding, which is a bit complicated, I would say. So here, with libcst, you can just use paren, and everything just works fine. And here, you can use deep equal, which is not supported by AST. If you pass the same module with AST and you try to compare there are they are the same AST, but they are different objects, then you will compare the ID of it, so they won't be equal. But CST actually provides this feature, and it comes with a better way for you to update the things you want. You can update, like in this example, I only update the default value of this node with the parameter node. Yeah. And this time, yeah, it's a bit different. It's your source tree need to visit the transformer instead of the transformer need to visit the tree. It's kind of weird, I know, but it's not that different from AST. So yeah, I think we are fine here. And yeah, everything looks good now. So the comment is actually preserved here, and the format we want is actually preserved as well. Yeah, here I actually add a missing import here as well. So that's not in my example, but it's fixed anyway. But the issue is that it takes almost 1 minute to process like 400 modules, and AST only take like less than 1 second, and like half of them would be loading the files. So CST, because it's preserved much more details, it can be quite slow. So yep. So the step we can use is that I try to use AST to filter out the modules that might contain an error, and later I'll try to use CST to fix those modules. Yeah, so that's basically how I did in this PR. And how do other tools like Black or Rough work? Yeah. Actually, they are still building their syntax tree, but they are not using AST or libcst. Yeah, this is how Black works in a super high level. Yeah, so it will first standardize the lines, like they'll remove or append the needing new line characters, and then it will pass the source code into a syntax tree. So basically, they are using lib223. This module was originally from Python itself, but it's kind of deprecated, I believe, in 3.11. So they have their own lib223 module in the Black package. And inside this package, what they are doing is that they try to get a grammar in the target version, because different version of Python might have different grammar, like the async version, the async keyword, or all those kind of stuff was added in 3.5 or 3.6. So if you are trying to reformat your code into 3.4, then you don't need those kind of grammar. And after you get the right grammar you need, and you then tokenize your code and build a syntax tree as a node object, which is pretty much the same as the AST we get in the previous example. And here, they'll try to generate line with line generator and with the node object. And this line is more like a logical line. It's not actually a line by line stuff. And it will transform the line into a line block. And at the final step, they'll just concat the line block here. So yeah, that's how Black works. And if you are following the slide, these are actually the link to the source code. So you can check the code a bit if you're interested in how Black works. And this is the node object of the same example, a equal to 1 plus 2. Yeah. And it will also try to pass it as a line object, which is what we are going to write into our module after all the processing. Yeah, and Black also used MyPyC to do the optimization. So the internal design need to match what MyPyC need. So yeah, that's Black. And for Rough, yeah, I'm sorry, I don't actually know Rust much, but I try to trace the module a bit. They actually still have a Rough Python AST, so they still have a visitor, and they are try to compare the node, the NAND, and try to pass it as an syntax tree. So yeah, all these kind of tools are still doing the things in pretty much the same way. Yeah, and yeah, as I mentioned in the title, I promised that I'll give you some like chaos stuff. So yeah, probably we can try to change all the snake case into like camel case, like the Java way or other language way. But That's quite boring, right? So, yeah. And what about this? So every time I saw this kind of like K8 or I18, I was super confused by what actually those words are. So that's what I'm going to try. Yeah. So let's try to formalize the step a bit as well. So because if you just change the name of building, it won't take effect. And the dunder methods, yeah, Python just, yeah, even if you change the dunder init to dunder like I2T, it's no use. And anything imported is not useful as well. And the target of our example will be change the top level variable class and function names into those weird things. So we first exclude the dunder method, which are the function name with double underscore behind and after that. And we'll also exclude the buildings. Then we'll try to visit import and import from. So in this example, if you import numpy as np, we'll try to add np as part of the import names we are going to exclude in our sample. And here is where we try to gather the words we are going to change it into the weird names. So it's a class definition, function definition, and also some of the variable names. One thing interesting here is the generic visit. So by visiting a class definition, AST expects you to process all the class definition, including all the function definition inside it. So if you don't specify the generic visit, then the next method, visit function definition, will not process any of the class method. So that's why we need to call generic visit here, because we want to change the top level function and also with the class methods as well. So this is how we generate our mapping, but this is not important, so we're going to go real quick. And that's how we try to do the number stuff and change the name. So we'll use this to generate a mapping and use that mapping to pass into a CST transformer. And after we leave, we'll just use the mapping here. So we'll update the value with the mapping we pass it. And it will change itself into this kind of unreasonable stuff like N10E. Who will know what this actually is? So yeah. But there's still some limitation of this example, like if there are name collision, because we didn't use the scope metadata or all those kind of stuff, it cannot handle name collision well. And if there's inheritance, like if you inherit from another class, and that class was inherited from the base class, you change that name, it just won't take effect. So it's turned out if we want to bring the chaos correctly, it's tough as well, but yeah, it's fine because we already bring some kind of chaos to our Python code. And I actually wrote a few blog posts related to this talk, so if you are interested, you can scan this code as well. There might be 2 or 3 articles to come, but yeah, that will happen like late October, I believe. Yeah. I'll step here for 10 minutes, 10 seconds, 10 minutes, a bit too long. Oh, actually, I still have a few more slides, so yeah. Yeah. And, yeah. So there are some related PyCon talks as well. Most of them are in PyCon US. The first one was from Charlie, the author of RAF. It actually tried to showcase how RAF works and showcase his passionate on the performance improvement, which is quite amazing, I would say. And the second one is Black. It's PyCon US 2019, I believe. So it was back to the time Black was first introduced. And the third one is the one from Czech, which I mentioned about the CST, libCST stuff. So yeah, I guess I just forgot to introduce myself a bit. So I'm Wei, and yeah, I'm volunteer at PyCon Taiwan for like 5 or 6 years, but this is my first time I speak at PyCon Taiwan. And yeah, because I'm a committer of Apache Airflow, so that's why I use Airflow as an example of this talk. And if you want to reach out to me, here's my GitHub and my LinkedIn. And yeah, unfortunately, this code doesn't work. So yeah, I'll lead a sprint with TP on Monday as well. So if you're interested, you can also join us. Yeah, we'll let you to contribute Airflow hand by hand. Yeah. Yeah, so this is the actual end of our talk, my talk. So yeah, so let's check whether there's any questions. Okay, so I guess I'll just go with the first one, or?
Okay, so if you might repeat the question.
Oh, okay. So how many rules like this does Airflow have? Is this kind of check common? I feel like yes, because the reason why I use the AST in the complicated way is that I try to mimic how other people did. So I believe there's 10-ish rules. Yeah, I don't actually count those kind of rules, but if you search for AST, there's some of like 10 modules, I believe. We use pre-commit to check whether the contributor do the things correctly. So, yeah. And will a hybrid AST CST solution be challenged due to the maintenance pain for developers? What else solution have you explored? If we want to keep the performance well, I would probably say just go with rough, because you can actually plug new roles to rough, and rough actually have some roles for Airflow as well. So we, by we, I mean Airflow community, we are actually discussing where we want to use rough for our migration, because we are going to release an Airflow 3 like in next year or so. So we need to do some automation so that people from Airflow 2 can migrate from 2 to 3 easier. And this is something we are still trying to do, but libcst is one thing we are thinking of, but it's way too slow. So if you have 1,000 like Airflow decks to migrate, it would take hours, I believe. I'm not quite sure. It depends on how complicated those decks are. So yeah, we'll probably need to try to search more, or just try rough, because rough is apparently super fast, but Rust is difficult. Yeah. Yep. If there's any question, you can just raise your hand, or I guess we can stop our sharing here. And yeah, you can reach out to me. Oh, yeah, please.
Is the libcst, can it be faster? Like, is it inherently slow, or could it be rewritten to be faster? Like, is this, the time difference between AST and CST is very large. So can it be improved?
Yeah, I believe there's a way libcst can be faster, but in its documentation, it's already said it's by nature slower. But the code module stuff I mentioned much earlier, there's a feature that you can add info. There's actually a way you can make it faster by, yeah, I did not dig into the detail of it, but if you're interested, code module is something you're looking for. Yeah. Yeah. Yeah, then I guess that's it. I'll just hand it over to Kevin.
Okay, so thanks everyone for your attendance, and we will have a next session at